In this video, we're going to look at how to analyze an equation of an ellipse centered at the origin. Given the equation, we're going to find all the features of it. So there's two versions of equations of ellipses. This first version on the left has a major axis that's horizontal. An ellipse, remember, is a stretched circle, a special version of an oval. And the version on the right here has a major axis that's vertical. The key feature, the way to tell, is that A is always bigger than B. So if A is bigger than B, we're looking for under which variable is the larger number, right? So if the bigger number is under the X, that means it is stretched horizontally, so the major axis is along the X-axis, or if the bigger number is under the Y, then it's stretched vertically and your major axis is the Y-axis. So given this equation right here, x squared over 9 plus y squared over 4 equals 1. That is an equation of an ellipse. We're going to find all of its features, the vertices, the foci, and the lengths of its major and minor axes, and sketch the graph. Well, the first step in doing that is to determine which way it is stretched. So we look at, okay, 9 and 4, comparing those, 9 is bigger than 4. Therefore, this thing is going to have, because 9 is bigger than 4, so that tells us then that the major axis is horizontal along the x-axis. The major axis is horizontal because the larger number is under the x squared. Okay, and what we can do is compare that to this version of the equation and say, okay, the 9 under the x squared must equal that a squared. Let's set those equal, right? This a squared has to equal that 9. So if a squared is equal to 9, and we consider a and b to both be positive, so when I take the square root of that on both sides of that equation, we only consider the positive root 3. So a is 3, and then we can do that same thing with the b's, right? The b squared is going to equal to 4. Taking the square root of both sides, we take only the principal root, and we get b is equal to 2. So those numbers, those are the endpoints of our major and minor axes, okay? So when we go to graph this, that's where we plot those endpoints, all right? So let's do that here. So if the center is at 0, 0, right? The endpoints of the major axis are here at 3, 0, 3, 0 is one vertex. We can put V for vertex. And negative 3, 0 is the other vertex. Now the endpoints of the minor axis don't get a special name, but they're just called B, right? So 0, 2 goes there. Well, I'll go ahead and label it 0, 2, and 0, negative 2. Now the foci don't really appear in the graph, but we'll find those after we sketch the graph, right? So to sketch the curve, we're really just going to I'm just going to hand sketch in. It's in a stretched out circle. So imagine you're trying to sketch a circle that has been stretched a little bit, kind of like an Easter egg, but without one side being too lopsided. All right, and there's our ellipse, right? So the foci are those special points on the insides at which the sum of the distances from each foci to any point on the ellipse is a constant. So to find those foci, we're going to use the special equation that says c squared is equal to a squared minus b squared. And that relationship is true for any ellipse, and it was derived in a prior video. The foci are at the point c, 0 and c negative 0. So they're on this major axis here. And we can use this to solve for that c, or that x coordinate of the foci. So we know a and we know b. In fact, we know a squared is 9 and b squared is 4. So we know c squared is equal to 9 minus 4, which is 5. So c is equal to the square root of 5. All right, now just for plotting purposes, because I do want to plot those on this graph, I'm going to do a quick rough estimation of square root of 5. Since the square root of 4 is equal to 2, square root of 9 is equal to 3, it's a little bit more than 2, so just go out here a little bit past 2. We'll call that a focus at root 5, 0. And a little bit past negative 2 there. There is our other focus at negative root 5, 0. Right? And the sum, let's just to review this here, right? The sum of the distance from the focus to any point on the parabola, that distance plus this distance is equal It's constant. So pick any other point on here, maybe right here or so. That distance plus this distance is equal to this distance plus that distance. Last, we're going to find the length of the major axis and the minor axis. So that major axis goes from this vertex to that vertex. And so its length, the length of the major axis, is always going to equal twice as long as A, double A. A was equal to 3, so 2 times 3 here is 6. That's the distance from -3 to 3. And then we do that same process here for the minor axis. So the length of the minor axis is always equal to 2 times B. B was that distance from there to there. So 2B is equal to 2 times 2, which is 4. All right, so that's it for that problem. And next, what we're going to do is a very similar problem. We're going to find the foci of that ellipse and sketch its graph. Now, we are given the equation, but it's not in standard form, right? This one says 25x squared plus 9y squared equals 225. So to put it in standard form, which you may recall, right? Standard form is either x squared over a squared plus y squared over b squared equals 1, or maybe the a and b are reversed, right? It depends so on which number is bigger. So if the larger number is always a, right? So it may be of the form x squared plus b squared plus y squared over a squared is equal to 1. So that's the first step, is to make one side 1, and we don't want to subtract 225. So in this case, we're going to divide everything by 225 to put it in that standard format. So when we divide both sides of this by 225, that first fraction, 25 over 225, 25 goes into 225 9 times. So that's going to reduce to a ninth. I'll put that over here. So we'll have x squared over 9 plus the second fraction, right? If you divide that, 225 divided by 9 goes in 16 times. So that is going to be y squared over 16 is equal to 1. All right, so with that, the bigger number in this case is actually under the y squared. So we are using this version of the equation, which means it is stretched vertically, which means the major axis is vertical or along the y-axis, right? So that right there tells us that the major axis is vertical because the larger number is under the y squared. All right, so we can set that equal to this right here, the a squared. Let's do that here. The a squared is equal to 16. So if I put a squared is equal to 16, now a is always a positive number, so we're going to take the principal square root and get 4 for a. And then we can do the same thing with the b's. The b squared would equal to 9, which then gives us that b is equal to 3. And those are the endpoints of the major and minor axes when it is in standard form at the origin. So the minor axis, right, is horizontal. We're going to go from -3 to +3. We'll plot those two dots there. And the vertices on the major axis go up to 4 and down to -4. So to sketch that ellipse, you just kind of hand sketch it in best you can. A little bit of a stretched out circle going through those 4 points. My graph's not quite perfect, but you get the idea here. All right, there's a great graph. Now, the only thing left to find is the foci. The first thing it says, find the foci, right? So on an ellipse, we can use the special relationship between A, B, and C, knowing that the foci, if it's got a major axis that's vertical, right, then the foci are on that y-axis. So we're at the point 0, comma, plus or minus, we call it C, and we know that C squared is equal to A squared minus B squared, and that was derived in a prior video. All right, we know a squared and b squared, so we can plug those in to find c squared. A squared was 16 right here, and b squared was 9 right there. 16 minus 9 is 7, so we get c squared is equal to 7. So c is the square root of 7. So that tells us that our foci are at the points 0, comma, plus or minus the square root of 7. For a quick estimation for plotting purposes, right, we know that parentheses there we go. We know that Square root of 4 is 2, and square root of 9 is 3. So bit between 2 and 3, there's our focus right there at 0, comma, square root of 7 approximately, and between -2 and -3, we have the other focus at 0, comma, negative root 7. And that is all for this problem.